Till last session, we have completed all the bins, right? Different types of bins and transition bins. Did everyone gone through that session? Examples?
Yes, ma'am.
Do you have any doubts, Chandana, Nilesh?
Ma'am, I don't know how cross bin is working, ma'am. That cross coverage
Cross
at the last.
coverage.
Yes, ma'am.
Okay, cross coverage we discussed, right, already
Yes, ma'am. Already discussed, but the example given in that PDF, I don't understand.
in the PDF. Okay, so okay, we will discuss. Others, do you have any doubts? So transition bins are completed, wildcard bins, nothing but parallel bins, like parallel case. However, we put jet high impedance thing. We will see. We'll look into ignore bins and illegal bins. What is the difference? And cross coverage. Okay. So C1 cross C2. Checking for C1 cross C2, nothing but AB cross coverage. Okay. So like this also we can write, or else in the first session we have written cross coverage. In the first session have shown for 2-bit size. 2-bit size means 4 combinations will be there, and also within that 4 combinations we will take all corner case scenarios also. So for some operation, so for cross coverage, how we took, this is what cross coverage. Okay, so here we have written cross point, coverage point A, coverage point B. For cross AB, we are checking cross coverage. Okay, so 2-bit size. 2-bit size means how many number of cases are there. A equal to 0, 0, B equal to 0, 0. A is constant 0, 0. B is changing 0, 1, 1, 0, 1, 1. So every cross coverage, in the sense every scenario we need to check. Okay, and every possible combination. Here 0, 1. So A is fixed 0, 1. B is changing 0, 0, 0, 1, 0, 1, 0, 1, 1. Like that 3. Like that 4. Okay, test case 4. Explain these cases, right? Same here also. It's a 4-bit size. 4-bit size means how many cases you will get. 2-bit size means nearly we got 16 number of combinations. Okay, for 2 cases. So for 4, nearly 64 cases we will get. Okay, so you need to run 64 different cases. You need to check cross coverage for that. How many hit, how many not hit. Okay, so take a simple example. You can put same A, suppose 3 down to 0 is there, right? If I put here uh, 3 down to 0, and here also sum 3 down to 0. Okay, you can generate the scenarios and check what are the cases. Okay, so in that how many hit, how many not hit. Did you understood the point?
Yes, ma'am. Ma'am, does our coverage also considers the constraints given in the test case?
Yeah, it will
Okay.
consider constraints also. But the constraints are nothing but different test case scenario functionality. right? To check the functionality, we use different cases, test cases, nothing but constraints. Okay, so coverage is nothing but to hit those test cases. Okay,
Okay.
coverage is just number of hits. 25. It is checking for each case A and B. So 100% coverage means we got just 25% coverage, and 6% coverage because lot of pins are not covered, right? 16 4-bit means nearly 64 combinations will be there. Okay, write down like this in terms of test case 1, test case 2, test case 3, 4. Okay, write down. You can also use for loop or any loops. Okay, you can use any loop to check the coverage for this. Okay, concept wise clear, right?
Yes, ma'am.
Okay, next, what is the difference between illegal bin and ignore bin? What did you observe the difference between illegal and ignore, everyone?
Illegal bin means if we mention some bins in that illegal bin means if that particular bin hits, then it will be considered as illegal bin, ma'am. Uh,
Okay.
Ignore bin also same as illegal bin, but instead of consider is it as a illegal bin and printing the output, instead it will provide error, ma'am. It will show some error
Hmm.
in illegal bin. But in
Okay.
EDA playground, it is not showing like that, ma'am. Both are working same.
Okay. 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 We will check. So illegal bin is nothing but what is the main purpose of illegal bin means it specifies the values or scenarios that should not occur under any circumstances. Okay. Any of these values or scenarios occur, it signals the problem. Okay, in the design it detects as a bug, it gives as a bug. Okay, so whenever the sample falls into illegal bin, it generates an error or warning depending on the tool settings. Okay, in EDA playground, if it doesn't give, you can change the tool settings and you can try with some other tool. You will get some clear information. Any one of the tool will give. It totally depends on tool. Okay, and coming to the ignore bins, what is the illegal bin? Everyone, whatever the specified values or scenarios that should not occur at any circumstances. Okay, any of these values or scenarios do not occur. If occur, it detect a bug. Ignore bins or nothing but we need to ignore those bins. See here, ignore bins, nothing but whatever we need to exclude certain values or certain scenarios from the coverage calculations without signaling an error if they occur. Here ignore bins will not get any error. So simply it is not counted in the coverage report. Okay. So main difference is I will write here. So illegal bins, nothing but value that never occur. Okay, should not occur. And also it generate the error or warning if hit. Totally depends on the tool. Okay, next, ignore bin. Ignore bins or nothing but it uses to exclude from the coverage count. Okay, so mostly it excludes the coverage count. Next, it doesn't give any error and it just ignore in the coverage report. Okay. So what are the examples we can write? So that is what the difference between illegal bin and ignore bin. Okay. So next example of ignore bin. I'm considering the same example. These are most important questions in interview point of view. Okay. So everyone don't skip. So for coverage, we need to write run.do file also, right? Before some of you asked, I think Sanjay, you asked how to open the waveform, right? To
Yes,
open the waveform, we need to write a dollar dump file and a dump where in the test bench.
it's taking so much time, ma'am.
Huh? Left side there are options to open the waveform. So here if you click on open waveform, it will automatically open the waveform, but you need to write dollar dump file and dump wares in the test bench. Okay. To open
Okay,
the
ma'am.
here for coverage we need to write the run.do file. Why? Because to upload the coverage, to extract the coverage, we need to use some script commands. Okay. So here for EDA playground we have default script commands. You can copy from the Google also, you will find anywhere in the EDA playground. So you can use those commands in the run.do file. Okay, after that just click on use run.do file here, so that do run, it will give the coverage report here. Okay. So here it's not giving for every bin particularly. So what we need to write to give for every bin? Here there are some bins, right? Ignore bins. To generate particular bin values, what we need to specify in the cover
Option dot per instance equal to 1.
option dot per instance equal to 1, so that every bin to bin it will check. Okay. See, bin 0, 6, 7, ignore bins, every bins it will check. Okay. So ignore bins means what here? Program bit y value dollar in the sense it is some q. Okay. And uh, what are the values we are considering? 1 6 3 7 3 4 3 uh, 5. Okay. So ignore bins means it doesn't give any error, but if you return in the coverage, it just ignore the coverage report. Okay. So what will be the coverage here? How much coverage we must get? 1, 2, 3, 4, 5 are there. So in the coverage here, in the list, there are 1, 6, 3, 7, 4, 5. So what are hit and what are not hit? Hmm? What are hit and what are not hit?
Six and seven will be hit, ma'am. Remaining will be ignored, I think.
Remaining will be ignored. 6, 7 are hit. Okay. So whatever we mentioned within the coverage, those are ignored. Remaining all are hit. Okay. So out of how many different values are there? 1, 6, 4, 5, 7. Total 5. 1, 3, 4, 5, 6, 7. Total 6. So out of 6, how many are ignored and how many are hitting?
5 bins are ignored, ma'am,
Hmm.
and 1 bit will be hit.
1 bit is hitting.
1 bin, ma'am. 1 bin will be hit.
Okay. So what will
But
be the
ma'am,
coverage?
there are multiple threes, right, in values, ma'am.
Multiple threes. Yeah.
Oh,
Even if it
but
is
in the
1
ignore
3 or
bins, we
multiple.
mentioned only 1 3, ma'am.
Okay. But
So,
even it's a 1 3 or multiple number of 3, it will take one time same value only, right?
okay.
It just
So
take as a
we don't
3 only.
need to mention 3 times, right, ma'am, in ignore bins.
No need.
Ma'am,
Just will
actually 2
mention
bins will be hit, ma'am. I think 6 and 7 will be hit.
6 and 7 will be hitted out of.
Because in ignore means you mentioned 2, no, ma'am. But in test scenarios, we did not provide that 2. But we
Okay.
have 6 and 7. So I think 6 and 7 will be considered as separate bins, and the 2 values will be hit.
Okay. Then what will be the percentage? Out of how much percentage will get?
25%.
33 percentage. How 33 percentage?
25.
35.
25, ma'am.
25, I guess.
Okay. Here all possible combinations are 0 to 7. That means 0 down to 2. 3 between, so total 8 combinations. 8 combinations means 0 to 7. Okay. In that 0 to 7, 5 combinations are ignored. Okay. How many remaining expected combinations? 3 are expected. That means 0, 6, 7.
6 and
3
7.
are expected from this list. But in that 3, 1 is not taken in the test case. Only 2 are considered, right? So out of 3, only 2 are hitting and 1 case is not hitted. Okay. That's why we will get out of 3, 2 hit. So 66.66% will get. Suppose if we do for this case, if I put 0, we will get 100% coverage. Okay, but before we got 66.66%. What bins are covering? 0 is not covering. So for 0 we got as a 0 and a 6 is covering and 1 is covered. And what are the ignore bins? Total 6 number of ignore bins are there. 0, 1, 2, 3, 4, 5 and 3 times hit 3 threes, right? So 6 number of hits. And these are covered and not covered. So I'm doing run again. So now we'll get 100% coverage because I included 0. Okay, 0 already, 0 included. So 100% coverage. and I'm removing 3 here. Okay, 3 is not repeating multiple times. Now we'll see how many ignored bins will get. Number of hits. Number of hits will be 4. Okay, I have removed those 2 threes. That's why 4 we got. Okay, so 1, because 2 is not there, right? In the list 2 is not there, so 1, 3, 4, 5, those are ignored pins. That's why 4. Before I removed 2 threes, so in place of 6 we got 4. Okay, so whatever we mentioned in the bin, those must be ignored, and whatever the possible combinations are there other than these ignore bins, we need to get according to the possible combinations in the main test. Okay, in that possible combinations, again it will check what are generated and what are not generated, because before we didn't used 0 in in that list. So for 0 it doesn't generated the coverage. For remaining 6 and 7 it generated the coverage, right? So that is what the difference. Ignore bins. Okay. Illegal bins means
It throws some error if that particular pit is hitted, ma'am.
bins are available in the okay. It throw the error, because suppose here same in place of ignore I'm just using illegal. Illegal bins. So 1, 2, 3, 4, 5. So here 1 is used, 3 and 4, 5. Those bins are used here. We should not use in the illegal, because those are illegal bins. We cannot use in the coverage. We cannot cover those values. Okay, so that's why we should not use here, so that it will throw the error. Okay. So what will be the coverage report now? See here. For 1, 3, 4, 5, which are used in the main test, and those are hitted in the coverage. Okay, so illegal bin was hit with the value 1 iteration. It will have no impact on the coverage statics, but it cannot do the sampling. Okay, so illegal, it's an illegal. We got error in this tool, but we will check how we will get the error in the cadence. Okay, cadence, we need to use different run script. Script file is different. Every tool have its own script commands. Okay. Here also we got error. Illegal state bin was hit at value 1. The bin counter for illegal bin. Okay, so it is not accepted. And here also illegal state bin hitted for value 3, so it is not legal. And here, okay, coverage report is not generated properly for this tool also, because we need to use proper command. Okay, okay. Okay, I'm using all deck only. Okay, now what will be the coverage? What are the expected and what are the not expected? What is the coverage report in this case? 1, 3, 4, 5 are illegal. So 1, 3, 4, 5 got the error. So what are the remaining values? 0, 2, 6, 7. Okay. Out of 0, 2, 6, 7, what are the values we got? 0 got, 6 is there in the list, and 7 also there in the list. So all these are covered. Okay, 2 is not covered. So if I
Because 2
put
is in illegal bin, ma'am.
2 is a illegal bill. So if I put 2, it go to the here, right? So 2 got into the illegal bin. Remaining all are covered. Suppose if I am removing 2 and 0. Now what will be the coverage? 0 will be not covered. So 66.66% we get. Right? 0 is not covered. 66.66 and illegal bins are 4. Okay. Is it clear everyone what is the difference between illegal and ignore bins?
Yes, ma'am.
Yes, ma'am.
Others?
Yes,
Padmakar?
ma'am.
Now? Okay. Morning I have shared before just before 1 hour. I have shared the coverage and assertions assignment. How many of you gone through that? As of now, just look into coverage only. In the next 2 sessions, you can work on assertions also. Okay, just skip assertions questions in that material, and whatever the coverage related questions are there, you can work on those. Okay, so I got few examples how we can write the coverage report for different scenarios if you observe, so that you will get some idea while you are working with some uh, projects and all. Okay, see first example, detecting overflow in an 8-bit adder. Adder means it's a full adder, suppose full adder or half adder. Okay, there are two number of inputs A, B, and output will be sum and carry. So carry we can call here as a overflow. Overflow is nothing but whatever the extra value is there, that value will sit into the carry, right? So that signal, that value we can consider as a overflow. Okay, so what is the problem statement here? Verify that an 8-bit adder correctly handle cases of overflow. Okay, in which case we get the overflow? Suppose it's 8-bit adder. If you consider in 8-bit adder, in which case we get the overflow? That thing we need to observe. Or else if it is tough, because 8-bit means we need to generate 2 power 8 number of combinations, right? It is tough to generate for all. Just take a 3-bit size for A and B. Okay, 3-bit size means you know there will be total 8 combinations. If you do 8 combinations addition to all with all, in which case we get the carry or not. Or else take 2-bit size. A is 2-bit, B is 2-bit. So in which case we get carry. Mostly we get in 1 case, right? So just observe and code explanation. I mean coverage code. The adder adds two 8-bit numbers and generate an overflow signal. When the sum exceeds 8-bit capacity, the coverage check. Okay, so you need to check in which case the sum exceeds 8-bit. Okay, because every time we don't get within the 8-bit range. So whenever we are doing some 2-bit value addition, in some cases we will get more value. Suppose 3-bit A is 3-bit and B is 3-bit. Suppose in the 3-bit you are doing 7 plus 7. 7 comes under 3-bit. For B also 7 comes under 3 bit. But 7 plus 7, it's a 14. 14 means comes under 4 bit size. Right? So 1 bit is extra. So it exceeds 1 bit. In that case, it checks the coverage. Okay. So all possible values for output 0 to 255, check the overflow and write the coverage. That is what the problem statement. Okay. If you are confused with 8 bit, you can also try with the 2 bit after the session. Okay. So here if you observe the design first, module adder 8 bit, input A and B, sum also 8 bit, overflow, nothing but carry. Okay. So here just used concatenation operator, assign overflow comma sum equal to A plus B, addition operation. Okay. So how we can write the coverage report for this? First we will see simple examples, then next session finally we can look into some project level. Okay. So see here, AB are declared as a rich data type, sum as a wire, and overflow carry, and instantiation DUT. Now coverage, cover group name, cover point for sum. Okay, for sum, bin all sums. All sums means what? Whatever all combinations are there, it will check for all the value. Okay, like this. If you put this type of brackets, it will check for all, not as a 0 bin, not as a 1 bin, 2 bin, 3 bin, 4 bin, not like that. It checks for whole array. Okay, 0 to 255. And cover point for overflow. Overflow cover point bins overflow. Overflow how many bits? Only 1 bit. So no need to write the array here. It will check only for 1 bit. Okay, if 1 we get. If we get carry as a 1, then only it's a overflow, right? 0 is not considered because 0 means it doesn't have any value. So 0 is not considered. Okay, only 1 is considered. So 1. Okay. Next, created the instance of coverage and initial for I equal to 0 to I less than 256. So all sequences generating in a for loop. So here there is a cross coverage. Before some of you asked cross coverage, right? In the cross coverage, we return all the values manually. Manually in the sense 0, 1, 2, 3, 4. Like that each value is generated. Or else you can write the for loop like this. Okay. So here I equal to 0 to 256 and j equal to 0 to 256. So I is assigning to A, B is assigned with the j values. Okay. And my COV dot sample. In coverage, we do the sample, right? Then only we can get the coverage. Do run and check the coverage report. So what will be the coverage report here? How many overflow will be there in this case? Hmm? 100% coverage. So write option dot per instance equal to 1 so that it will check for every bin. So how many bins we will get now? 256. Total 256. In 256 bins, all sum are covered and overflow covered. Okay. Suppose if I put only for overflow, in the 256 number of pins, how many number of overflow will be there? Oh, bin overflow only for this condition it is checking. So 100% coverage. Whatever the bins it have, only that it is checking. Suppose here I'm just using only 0 to 16. So what will be the coverage? Only between 0 to 16 combinations it will check. Remaining all or it doesn't cover. 0 to 6, all 256 are covered, and these are number of hits for coverage. We will check for 2-bit size, 1 down to 0, and here also 1 down to 0, and here also 1 down to 0, so that four combinations, right? So, and here 0 to 3, and here less than 4, less than 4. Okay, so what will be the coverage now? Obviously we will get 100% coverage because we are checking all the combinations and all combinations are hitting. Okay, 4, 4 and 4 all are covered. Suppose an overflow 6. If I am putting overflow as a 0, so that it doesn't cover for all scenarios. Okay, now 10. 0, 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, it should do with 0, 0, 0, 1, 1, 0, 1, 1. So in this case, 4 number of hits we get, and for this 0, 1, we'll get 0, 0, 0, 1, 1, 0, 1, 1. So here also 4 number of hits, and 1, 0, 0, 0, 0, 1, 1, 0, 1, 1. Here also 4 number of hits, and here again 1, 1, 0, 0, 0, 1, 1, 1. Okay. But in that, how many number of overflow you're getting? Did you understood everyone? Some 4 cases, 4 number of hits. Every time 4 number of hits we will get for each case. Okay. Bin 0, we get 4 cases. Bin 4, we get 4 cases. Bin 2, 4 cases. Bin 3, 4 cases. As I written here. Okay. Bin 0, we get 4 cases. Bin 1, we get 4 cases. Bin 2, 4. Bin 3, 4. Okay, now you need to check 0, 0, 0, 0. Okay, so all are 0. 0, 1, 0, 1. 1 for 1, 0, output is 1, 0. For 1, 1, output is 1, 1. So here we don't get overflow. Okay, now for this 0, 1 case and remaining case. Okay, so 0, 1, 0, 0, no overflow. 0, 1, 1, 0, no overflow. 0, 1, 0, 1. So output will be 1, 0, no overflow. 0, 1, 1, 1. So here we get output as a 1, 0, 1, 0 means 1. So here we are getting overflow. Overflow as a 1. Okay, overflow as a 1 time. Next 1 0 1 0 0 0, no overflow. 1 0 0 1, no overflow. 1 0 1 0. Here we get 1 overflow because 1 double 0. So second overflow we got. Okay. Next 1 0 1 1. Here also we will get overflow as a 1 bit because here 1 1 1 means 1 0, right? So 3 times we got. Till now 3 times overflow we got. Once overflow. And for 1 1 case, 1 1, are you able to understand what I am doing? 0 0. So no overflow. 0 1, no overflow. Okay. 1, okay, we will get overflow. Here 1 will get 0 and 1 1 means 1 0 we will get. So here we got 1 overflow. Okay. Next 1 1 1 0. Here also we will get overflow. Okay, another 1 overflow you are getting. And 1 1 1 1. So here also we will get 1 overflow. Okay. How many number of ones overflow getting? 1,
3.
2, 3, 4, 5, 6. Wow, we got correct output. See here, if I put 1 here, okay, 1's overflow, just run. We got 6 overflows, right? 6 number of hits, 6 overflow. Okay, for one case. Zeros overflow, if it is one's overflow means other than one's overflow, zeros only, right? Output is 0. Okay, if you observe, for here 1 overflow 0 we get, here 1 overflow 0, third 0 overflow, okay, and fourth overflow. Okay, here in this case 4 overflows we get. In second case, um, 0 1, compare 0 1. So 1, and here also 0 1 0 1. So 1 0. So here also we will get 0 overflow only. Okay, so 2 overflow, 1 0 1 0 0 1. Here also we will get 0 overflow only. 3 and 0 1 1 1 0 1 1 1. We got 1 overflow, so we won't consider this case. And 1 0 0 0, we will get 0 overflow, so in this case 1. And 1 0 0 1, we will get 0 overflow, so 2. 1 0 1 0, we will get 1 overflow, so don't consider. 1 0 1 0, we will get 1 overflow, so don't consider. And 1 1 0 0, we'll get 0 overflow, so first case. And 1 1 0 1, we get 1 overflow. And 1 1 1 0, we'll get 1 overflow. And 1 1 1 1, we'll get 1 overflow. So total here 4 5 6 7 8 9 10. Okay, for 0 overflow, total combinations, total what we say, possible values, 0 overflow values are 10. Okay, I'm just removing 1 here and putting 0. So do run and check. We need to get 10 number of hits for 0 overflow. Okay, we got 10 number of hits for 0 overflow. This is how we will check coverage for every corner case scenarios. Okay, did you understood everyone? Clear? Hello.
Yes, ma'am.
Is it clear everyone? Any doubts still here?
Mm.
Nilesh, Padmakar, Sanjay, and CB. Don't you understand?
Understood, ma'am.
Okay. Next for finite state mission. Okay. So how we can write for finite state mission coverage report? Suppose I am considering a simple FSM. Read the problem statement here. It verifies that a simple FSM covers all states, including an illegal state, if it occurs due to unexpected behavior. So, code explanation is the FSM has three states: ideal, active, and done, and transitions between them. Coverage checks. So, each state transition, illegal transition, or states that should be not encountered. Okay. So, FSM, it have clock, reset, and state. Ideal equal to 0, 0, active 0, 1, done 1, 0. Okay. So in place of parameter, we can also use in this way. And always at the rate of posage clock and reset, current state will be the ideal state, next state. Okay. For reset logic. And case state, ideal state, then next state is active. If present state is active, next state is done. If present state is done, next state is ideal. By default, next state is ideal state. Okay. So how we can write the coverage for this? To cover all the states 0, 0, 0, 1, 1, 0, 1, 1. Okay. See here simple cover groups. Bins for ideal state 0, 0, active state 0, 1, done state 1, 0. Next up 1, 1 is illegal. Okay, illegal means we cannot use in the main test. Okay, so it is a illegal 1, 1 case. So after run, if you use within the test, we get the error, right? Okay, we need to write the run.to file here. What is the error? Test bench.sv 20th line. Illegal means illegal states. Syntax error. Okay, coverage report is 100%. Just I will share you all the codes for FSM and memory also there. Try to work on FSM and memory. Okay. So for memory, address data equal to mem of address, write data, and how we are accessing all address, and ignore bins. These are reserved bins. Okay. So for the ignore bins, just difference between illegal bin and ignore bin. Observe the change difference. Okay, I will share this code after this session. So same, however, we are uh, taking in this way, just do in the same format. Okay, try to understand each scenario and check every corner case scenarios we need to understand. Okay, is it clear, everyone, till here? From tomorrow onwards, from next session onwards, we are going to start assertions. Okay, so if you have any doubts, if you want to practice more example, I already shared the assignment on coverage. So please work on that. That is best examples. And these also FSM memory and remaining also I will share. Okay. Any doubts for today's session?
No, ma'am. Need to practice.
Okay. Okay. Okay, then thank you all.
Thank you.
Yeah, bye.